I'm so excited for today's journal club. My really good friend Will, and amazing esteemed colleague Will, is going to be talking to us about IIT and some of his work. So Dr. Will Maynor is a researcher at the Center for Sleep and Consciousness at the University of Wisconsin-Madison. He earned his PhD in neuroscience in 2023 under the guidance of Giulio Tononi, and his work focuses on developing integrated information theory, IIT, and most recently extending its mathematical framework to offer an account of perception. He is the creator and maintainer of PyPhi, which is the open source Python toolbox for IIT analysis. And he's pretty cool. So I'm really excited to hear what you got to tell us, Will.
All right. Thanks a lot, Zarmeen, for the lovely intro, and thanks for the chance to talk to you guys about IIT. So I understand that you're kind of organizing a debate sometime soon about IIT and its sort of scientific status. I think probably many of you know that there's been some controversy around IIT. Some people have sort of argued that it's pseudoscience, and there was this infamous letter that was just published in Nature Neuroscience. So my goal for the talk today is basically just to give an overview of IIT at a very high level, just kind of focusing on philosophy of science issues. I'm not going to get into any of the mathematical details, really. That would kind of be several talks probably, but I'm just going to try to give you a sense of the sort of architecture of the theory, how the inferences sort of work, and then I'll try to address a few specific criticisms. So I think the first place to start with any talk about IIT or consciousness in general is what are we trying to explain? So this is super important because I think it's not always actually clear. I think there's a lot of different theories of consciousness and they can be about different things. So for IIT, the goal is really to explain subjective experience as such. And there's this phrase, what it is like to be you, that's often used to get at that idea. So this is due to Thomas Nagel, who wrote that an organism has conscious mental states if and only if there is something that it is like to be that organism, something it is like for the organism. And so that's kind of what we're trying to get at and what IIT is trying to explain. And importantly, that is distinct from other things that we might try to explain using typical neuroscience methods like attention, self-awareness, report, cognition, emotion, memory. What we're really trying to explain is why any of these things feel like something. So there's basically two questions that IIT is trying to address. Why is experience present versus absent? And then why do specific experiences feel the way they do if experience is present? So this is a problem that has been described by David Chalmers, a philosopher of mind who's worked on consciousness for a long time, as the hard problem of consciousness. So he writes, it is widely agreed that experience arises from a physical basis, but we have no good explanation of why and how it so arises. Why should physical processing give rise to a rich inner life at all? It seems objectively unreasonable that it should, and yet it does. So this is the problem of trying to look at brain mechanisms and somehow get from there to an explanation of why any of the complicated neural activity happening in the brain should give rise to a subjective experience. And so at this point, I kind of want to argue that subjective experience is sort of a special explanandum. It's a special target of explanation in science. Because in most scientific endeavors, you're trying to explain something that everyone else can sort of observe, right? But subjective experience, one of its defining features is that it is accessible only to the subject. It's sort of private. And so for that reason, I think it's unlike pretty much any other target of explanation in science. And this basically provokes a few different responses. So one is just outright denial that it's special, that there's anything really to explain. This position is sometimes known as illusionism. And then, people advocating that position would argue that actually what needs to be explained is why we think experience exists, but that there's actually nothing special about it. It's just like any other target of explanation in science. Now, the IIT folks, we would argue that this is actually absurd because experience is sort of the one thing that we really know exists. And at the very least, even if you don't think it's absurd, I would argue that it's a bit contrived. You're trying to explain something by simply sort of explaining it away. You're kind of not tackling the actual problem, trying to sort of find this strange argument that the thing that you wanted to explain isn't even real. So I don't find that very satisfying. There's another approach which argues that, sure, there's this sense that the hard problem is very hard, but maybe if we just keep doing neuroscience and we keep explaining the mechanisms of the brain, solving all the so-called easy problems, this will eventually dissolve the hard problem. Now, that may be the case, but it's just unclear how exactly that would work, and I don't think that we've made much progress so far, and it's not obvious how that would bridge the so-called explanatory gap um, between these easy problems and the hard problem. And then there's just, the third approach, which is the one that IIT takes, which is just to take phenomenology seriously, to say, okay, there is something special about consciousness. It's unique in this way, and we should, use that to our advantage when constructing a theory. So we think that's worth trying. Okay, so now I'm just going to give a kind of very high level overview of sort of the IIT methodology and the way that it approaches the hard problem. So this is a big diagram of how IIT works. I'm going to go through it step by step. So the first step is, instead of looking at the brain and then trying to find neural mechanisms that we might correlate with consciousness, which is a very useful thing to do, finding the so-called neural correlates of consciousness is very useful. But IIT takes a different approach. We're starting from phenomenology itself. So the first step in IIT is to introspect about our own experience and try to think about what are its properties, and in particular, what are the properties that seem essential to it. So IIT identifies 5 of these properties. I'm going to go into them a little bit later. But once we've done that, then the next step is to try to formulate those properties, these introspectively apparent phenomenological properties. We're going to formulate them in physical and operational terms. So we're going to try to translate those properties into physical properties of a substrate like the brain. And this gives rise to IIT's mathematical framework. And I'll get into that a little bit later as well. But the output of this procedure is basically we can take a substrate like the brain, and we can calculate something called a cause-effect structure. I'm going to describe exactly what that is later on in the talk, but for now, it's just a big mathematical structure. That's all you really need to know. And then the claim is that this structure is in one-to-one correspondence with the phenomenal structure of experience. So if we think about our experience, it has, many different structural elements, right? There's, like, take the visual field, for example, there's the left half, the right half, etc. We call these distinctions because you can distinguish them from one another, and then they stand in some relation to each other. So, certain parts of my visual field might overlap with other parts. And then the claim is that this cause-effect structure that IIT's mathematical apparatus gives us stands in one-to-one relation with these distinctions and relations. So we call this the explanatory identity. We're saying that all the phenomenological properties of experience can be accounted for by properties of the cause-effect structure. So once you do that, you've now sort of created the explanatory framework that IIT uses, and then you can sort of iterate on this process, and you can start trying to explain particular aspects of our experience, such as why does space, visual space feel extended? Why does, how does the perception of time work? How do we have perception of objects and colors? And the idea is that for each of these aspects of experience, you can find some part of the cause-effect structure, some physical aspect of it that explains or accounts for those phenomenological properties. So, a paradigmatic example of this is the experience of space, like I mentioned, the visual field. The idea would be that there's some part of the cause-effect structure, and there's some part of the substrate of consciousness, probably in occipital cortex, that explains and accounts for the phenomenological feeling of the visual field, how it feels to see. Okay, so that's kind of the overarching goal of IIT, the explanatory identity. Now, of course, you have to test it, right? You have to validate this primarily in healthy humans where we know what it feels like to be conscious. And you can validate it by looking at the substrate that seems to be necessary for, the conscious state of of an organism, and then you can also look at the particular contents, like I said, and try to examine, which parts of the brain give rise to which parts of experience. So IIT makes a bunch of precise predictions about this, and then you sort of go and try to test it. And I'll argue a little bit later why I think it is testable. Once you have validated the theory, then you can extrapolate beyond cases where where you know what consciousness is like. And so you can start to apply IIT or any theory of consciousness to cases where it's not obvious what is conscious or what it's like to be that creature, like an octopus or a robot or something. Okay, so that's kind of just a very broad overview of the IIT method. And now I'm going to try to describe the actual properties that we introspected in the first step and how they're translated into physical properties. So we call these phenomenological properties axioms. And these are supposed to be immediate and irrefutable properties of experience that are evident upon introspection. Immediate means they're immediately given. They don't require any further justification. They're just sort of evident when you consider your own experience. And irrefutable means that, if you examine your own experience carefully, it seems hard to deny that the experience has these properties. So this is all in the realm of phenomenology. This is not the realm of science yet. And then the idea is that we make an abductive leap from those properties to the postulates, which are properties of the physical substrate of experience that we are inferring must apply because because of how experience is. So this is kind of different than sort of the typical reasoning used in science, which is inductive reasoning. You do a bunch of experiments, you repeat them, and then you infer that, oh, this must hold across all examples because we've looked at a bunch of them. And so this is kind of how we formalize this form of inference. Once you do that, you're now in the realm of science. Now you have, you're talking about, third person properties that are accessible to everybody about a physical substrate. You can make predictions and then you can test them. And then again, we have this one-to-one correspondence, this explanatory identity between the cause-effect structure, which is what we get from all the postulates being applied, and an experience. All right, so now I'll try to describe the axioms and the postulates. So the first one is, we call it the zeroth postulate or the zeroth axiom. This is just the idea that experience exists. So there is something. This is, famously known as the cogito. Descartes made this observation that, you can doubt everything, but you can't really doubt that something exists. The cogito ergo sum. William James also made this observation in the Principles of Psychology. He said the first fact for us then as psychologists is that thinking of some sort goes on. So this is kind of the starting point for, I think, any theory of consciousness. To get off the ground, you kind of have to acknowledge that experience exists. So that's a basic phenomenological fact. And then we translate this to the postulate by saying that the physical substrate of experience can be characterized operationally by cause-effect power, which a scientist can then probe by manipulation and observation. And the link here is, goes back to the ancient Greeks who articulated this principle called the Eleatic principle. And basically what it says is that if something exists, it has to have a cause or an effect. If it didn't, then whatever ontology you have, whatever picture of reality you have, you could just take that thing out of it because there's no way to observe that it has any cause or effect on anything else. So that's why we think this is a good translation of this, first person phenomenological fact to a physical property. So we're going to be focusing a lot on cause-effect power. And this diagram is basically showing, a system, a dynamical system. The arrows indicate causal efficacy. And then we can intervene on this system and observe what changes in state will do to it. Okay, so the next axiom is the axiom of intrinsicality. So this is saying that experience is intrinsic. It exists for itself. And so this is getting at the idea that I talked about a bit earlier, that experience is subjective, it's private. This seems to be, an essential property of experience. It's part of what defines an experience. And so we think it applies to any experience. And then the way we translate this to the postulates is saying that the cause-effect power of the substrate of consciousness, of experience, must also be intrinsic. It must take and make a difference within itself. So we just said that the substrate of consciousness has to have cause-effect power. Now we're saying, okay, that cause-effect power has to be affected upon itself, within itself. So the parts of the substrate have to have some causal power over themselves. And that's illustrated here by looking at this part of the system that we've outlined in blue, and we're considering the causes and effects within that region, and we're fixing as background conditions the external units. The next axiom is the axiom of information. And this says that experience is specific. It is this one. So it seems, very clear that when you have an experience, you're having a particular experience that's different from any other experience. And the way that we translate this to the postulates is saying that the cause-effect power of the substrate of experience must also be specific. It must be in this particular state with a particular cause and a particular effect, and that's different than, other states it might have been in or other causes and effects. The next one is integration. This says that experience is unitary. It is a whole. It's irreducible to separate experiences. Again, this seems very clear. It seems like any experience you can conceive of is going to just be one experience. It's not like you somehow experience the left half of your visual field separately than the right half or something like that. And so the way that we translate that is we say the cause-effect power of its substrate must be integrated. It must specify its cause-effect state as a whole set of units that is irreducible to separate subsets. And so what this means in terms of IIT's calculation is that, we have a way of assessing causal power in a dynamical system. And now we're going to try to partition the system into different parts and see if we lose any of that causal power. And if we don't, then we know that what we thought was just one system is actually two systems or more, because all of the causal power in the system is accounted for by the parts. Whereas if that's not the case, then we know that the causal power is sort of irreducible. You have to consider the system as a whole in order to account for all the causal power. All right, the next one is exclusion. And this says that experience is definite. It is this whole. So I think we would probably all agree that, your experience clearly has a boundary of some sort. In the case of the visual field, again, it's very obvious. Obviously, you can't see beyond a certain range, but even if it's hard to attend to the border of the visual field, it's actually quite hard to see, there is obviously a border. And so that's kind of true of any experience, we argue. And the postulate for that is that the cause-effect power of the substrate must be definite. So it must specify its cause-effect state as this whole set of units. And so in the calculation, that's going to basically amount to saying that the substrate that we're identifying for a particular experience is going to be the one that has the maximum amount of irreducibility, the maximum amount of integration, and it's going to exclude overlapping subsets. All right, the last one, we're almost done, is composition. And so this is the observation that experience is structured, meaning it is composed of distinctions and the relations that bind them together. So I talked about this a little earlier. This is, the observation that there's many different elements of experience. Any experience you can conceive of is going to have some elements or distinctions that can be distinguished, and they stand in some relation to one another. The postulate for this is that the cause-effect power of the substrate of experience must be structured as well. And that means that the subsets of units in the substrate must specify causes and effects over other subsets of units. We also call these distinctions, and they can overlap with one another. Those overlaps are called relations. And the net result of all of this is that we have this very complicated sort of shape, this mathematical structure that we call a cause-effect structure. And that kind of captures all of the causal constraints that exist in the system. Okay, so that's the axioms and the postulates. That's the set of properties that we think are necessary and sufficient to constitute an experience, and then their translation into physical properties using this abductive move. And so the result of this is the mathematical formalism of IIT. And so the input to this is a dynamical system, and we need the complete description of it. We need all of the units and all of their causal relationships. And then we plug this into IIT's algorithm, and we get out this big shape, this cause-effect structure which is supposed to account for the quality of the experience that's being supported by the substrate. And then we have the phi value, which is supposed to be the quantity. And like I said, I'm not going to get into the particular details of how all the postulates I just described are combined into one mathematical procedure, but there's these papers you can look up, and there's also this excellent IIT wiki now that has very good explanations of how this all works. So I recommend you check those out if you want to look at the details. But that is kind of the overall structure of the theory. And now I'm going to kind of talk about some of the specific objections that people have raised. Some of them are cited in the pseudoscience letter. So one that got a lot of attention about 10 years ago is an objection from Scott Aronson, who's a theoretical computer scientist, and he has a widely read blog in which he looked at IIT and argued that it's not satisfying. And that was on the basis that it predicts consciousness in very counterintuitive cases. So he says that the test of a theory of consciousness is whether it can produce results agreeing with common sense intuition. And then he does basically some math to show that you can create a graph that has certain properties, the expander property, which more or less means that, you know, every part of the graph is pretty well connected to every other part of the graph. And he showed that you can construct a system that's going to have very, very high phi. And if you scale it up, you can make the phi arbitrarily large, you know, even larger than the phi of a human brain, let's say. And so his intuition then is that he feels very confident in saying that these kinds of systems cannot be conscious. And so to him, that is disqualifying for IIT. And I'm going to kind of lump this objection into the next one I'm going to talk about, and then I'll try to argue why I don't find this objection very compelling. But I also want to note,
just a
yeah,
quick question.
yeah, what's up?
So just to clarify, phi, this value of phi is going to
Mhm.
correspond to some, like how conscious a system is, right? Like the more phi, the more possibility for consciousness, or the more consciousness in general.
Yes, yeah, that's the idea. So the value itself is really best thought of as kind of a measure of irreducibility. It's kind of an overall measure of how well the substrate kind of satisfies all of the postulates together. And then the claim is that that corresponds to kind of the amount of consciousness. Right. Yeah, thanks for the question. And yeah, feel free to interrupt anybody if there are other questions. Okay, so this is kind of one objection that really turned a lot of people off of IIT, and it's cited in that pseudoscience letter. But I also want to note that in this blog post, Scott also said that almost all competing theories of consciousness, it seems to me, have been so vague, fluffy, and malleable that they can only aspire to wrongness. So thanks a lot, Scott. So it's kind of ironic that they chose this to support the pseudoscience allegation. All right, so now I'm going to talk about a related but slightly different objection, more recent, about 5 years ago, called the unfolding argument. And this is from Adrian Dorig and colleagues, and they claim that all causal structure theories, so this applies to more theories than just IIT, it's basically anything that deals in causal structure, and that of course includes IIT, are either falsified or outside the realm of science. All right, so I'm going to give a sketch of this argument that's due to Larissa Albantakis, one of my colleagues at the UW. And basically, they start from this example of just a normal, healthy human, you know, presumably conscious, and presumably has a non-zero, probably very high phi value. So the theoretical prediction from IIT is that this, you know, the brain would be conscious, right? If we didn't have that, we'd have a serious problem. So of course, this person's going to say, okay, I see a cat, I am conscious. And so these two agree. We have a theoretical prediction that agrees with the report. And then the idea of the unfolding argument is that you can use some theorems from mathematics that say that for any recurrent neural network, you can unfold that network into a feed-forward network where information is only flowing in one direction, there's no feedback, and it will perform exactly the same function. And so they use this to do the thought experiment where you substitute the brain of the person with a functionally equivalent feed-forward neural network. So by construction, the person's responses are always going to be the same as the robot's responses are always going to be the same as the person's. And now in the IIT calculation, if you analyze this feed-forward network, you're going to find that it has phi 0. And the reason is because it does not satisfy integration. Because information is only flowing one way, it's not an integrated system. So the theoretical prediction from IIT is that this is actually a fully unconscious system. And that is despite the fact that by construction, it has all the same input-output relations. So it's going to also report that it, sees a cat. And based on that report, you would think it is conscious. So that's kind of the argument from Adrian Dorig. And the claim is that, okay, well, in both cases, we have a report that it's conscious, but the theoretical predictions differ. So there's an issue. Now, this argument, I think, has several flaws that, these papers talk about. There were several responses kind of attacking it from different angles, but the one that I want to focus on for this talk is that it is implicit in this argument that we actually have to believe the robot when it says that it is conscious. Okay, so basically, Scott Aronson's objection and Adrian Durig's objection are very similar. So Scott is saying that there is this system that's constructed to have a high phi value, and that means there's this counterintuitive presence of experience. And Dorig is saying that there's a counterintuitive absence of experience. And the question I want to ask is basically, when are intuitions about consciousness well grounded? Because we have this intuition that this expander system should not be conscious. And we have this intuition that the feed-forward robot, because it has identical behavior, should be conscious. Okay, so the claim that I'm making is that intuitions are actually only well grounded in paradigmatic cases. So this is a plot of different kinds of systems that vary in their anatomical and behavioral similarity. Behavioral similarity on the y-axis, anatomical similarity on the x-axis, and at the origin is me. So I know that I am conscious. I can be 100% certain of that. And then, I'm very confident in my inference that all of you are also conscious. And now, why am I confident about that? Well, that intuition or that inference rests on two things. It rests on knowing that I'm conscious and then knowing that you are all very similar to me in terms of anatomy and behavior. And you can extend that out. I think a lot of people would agree that a dog is probably conscious, very similar brain in many ways. It has behavior that's somewhat similar. It seems to have an inner life based on, what we observe, etc. But then when you get further away from systems that are similar to you, I think that we can no longer really trust our intuitions about whether those things are conscious. Because we really only have access to behavior. We can't directly observe whether something is conscious, of course. That's kind of one of its defining features that makes it this very hard problem. And so all we have to go on are the fact that, I'm conscious, and then if something else is physically similar to me and it behaves in the same way, I can be pretty confident that it is also conscious. But if it's very different than me, then I really just should not trust any intuitions I have because it is just there's no grounding, right? I mean, and I think that this is made a little more clear when you consider the case of AI. So AI is, can be very similar to us. If you're just chatting with a chatbot, it can sort of seem like it's a person. But I think people would hopefully agree that it's not at all obvious if a chatbot is conscious because it does not have a brain. It's very anatomically different. So that's the claim, is that these paradigmatic cases are actually the only ones where you can really test theories of consciousness. And that when you want to make inferences about systems that are very different, that's when you actually need a theory in order to extrapolate to those cases. And so basically the idea is that these objections from Scott Aronson and the unfolding argument don't hold a lot of water because I just don't think that we should trust those pre-theoretical intuitions. They're not valid, you know, basis. They're not a valid basis on which to compare to a theory. And because if a theory sort of disagrees with um, the inference of consciousness in a paradigmatic case, like that you and I are conscious, well, then we would rather discard the theory than discard the inference, right? But in these other cases, I just don't think that that's so clear. Okay, so then there's another objection, which is from a philosopher, Tim Bain, and he's basically saying that the axioms are actually not axiomatic. So he says that the axioms are either not self-evident or they fail to constrain theories of consciousness. So I don't really find this so compelling, and the reason is basically that our claim is that the axioms are immediate and irrefutable upon introspection. So, we think that they're properties that apply to any experience. But of course, not everybody agrees about that. I mean, people don't even agree necessarily that consciousness exists, right? So the argument seems to be that in virtue of the fact that the axioms don't convince everyone, IIT must be wrong to anyone. And I just don't think that that is really a valid argument. I mean, we do think that they're very compelling axioms, but some people disagree. And so, yeah, of course, if you don't think the axioms are true, then that, if you don't buy them, then that kind of explanatory identity that we're proposing loses its force. But this is kind of a very banal feature. This is true of pretty much all scientific theories. They all rest on some fundamental grounding assumptions, and not everyone agrees about those necessarily, especially as the theory is sort of being developed in its infancy. And so I think this is maybe just more a misunderstanding about what the axiomatic approach is really trying to do. And as far as the failure to constrain objection, I mean, we think that these axioms, like I keep saying, are necessary and sufficient to constitute an experience. This is then the basis for this abductive move to the postulates, which are the physical properties of the substrate. And those postulates, when you put them all together, they do tightly constrain IIT's predictions. We then have this sort of elaborate mathematical procedure, and it makes this very strong claim that there's this identity between an experience and a cause-effect structure. So that is, a very tight constraint, I would argue. Okay, so
So,
yeah.
sorry, I keep jumping in here.
No, that's great. Yeah.
So as sort of any good theory, right, when you're collecting data, you go back and sort of update your assumptions, right? You update
Mhm.
based on what you're getting. So this argument about like the axioms not being axiomatic enough, like the axioms and the postulates are actively being worked on, right? Like there's room for addition and taking out. Is that true? Or is that like this?
I don't think so. Yeah, I mean, I think that the axioms I would say are really not like I don't think have ever really modified those.
Yeah.
Um, and I think that if we're forced to modify them, then that might become problematic, right? I mean, there's always a tension between, do you just admit that a theory is falsified, or do you try to sort of accommodate the new data? Or the challenge. And if you keep having to make ad hoc changes, then I think a theory starts to lose its scientific status, right? Um, and so I would say that if there's some compelling argument that the axioms are wrong, then I think I would abandon IIT. Um, but I think, well, yeah, I mean, maybe that answers your question. I guess the postulates, I guess I should address the postulates. So the postulates, there have been several different versions of IIT over the past 20 years. You have to start from somewhere and then you have to develop it. And I think that the question is this sort of a progressive research program or a degenerative research program? This is kind of a framework for philosophy of science from Lakatos. Nicola Negro mentions this in one of his responses to the unfolding argument. And I mean, I would argue that the research program of IIT, as the postulates get refined and the algorithm gets refined, is progressive. It's generating hypotheses, it's making predictions that we can test. And so in that sense, it's not so catastrophic if we're, developing the theory and refining it. But the axioms, I think, are pretty fundamental, and it would be challenging if we were forced to change them for some reason. But I just can't imagine what a reason would be. I have not heard a compelling argument to change the axioms so far. So maybe that answers your question.
Yep.
Okay.
I had a question, sorry. How
Yeah.
is this I guess this would be in relation to the exclusion axiom. How exactly is the boundary of the system defined? Because I know you mentioned like in the visual system as a small example, you do have an objective boundary, but I mean integrating all that information, at what point does something that influences consciousness get defined as something that isn't itself conscious, like the preset mood
Yeah.
influence my consciousness?
Yeah, that is a great question. Yeah, and we refer to those as background conditions, and of course they do influence consciousness. If the reticular system is not working, the ascending reticular activation, then you're not conscious, right? That's a problem. But that doesn't necessarily mean that that part of the brain is part of the substrate of consciousness. And so in the algorithm, the way that this works is that you're looking at the physical system, and then you're trying to establish which subset of the system is maximally irreducible. So we have this whole apparatus for testing irreducibility. You're making these partitions and you're seeing how that affects the causal power of the system as a whole. Um, and this is a scalar value, basically. So it's 0 if the system can be neatly partitioned into 2 or more pieces that fully account for all the causal power. But if it is an integrated system, then that partition will only lose some of the information that's being specified by all the parts about all the other parts. And so that gives you a sort of scalar measure of integration. And then the claim is that the substrate of an experience is the subset that is maximally integrated. And that's kind of the maximal phi value. So that's how the algorithm is identifying the border, right? So some units are going to be inside that border and some units are going to be outside. Does that kind of get at your question?
Yeah, sure. Thank you.
Okay. All right. So then, any other questions, or I'll move on?
Yeah, I actually have a question if I can jump in. It
Sure.
was about the question that Zarmeen raised about the changing of the axioms
Yeah.
that are grounded in experience. Like, for example, time and space aren't included as essential properties because it's conceivable that you can have, and people have experiences of timelessness, or it's conceivable that you can have an experience outside of space. And since we all do psychedelics research, can the axioms be challenged by experiences under psychedelics? Like when someone has an
Yeah.
experience of boundaries dissolving or a feeling of unity with the universe, obviously the experience is true and that's what the person feels in the moment. But why is this not a valid reason to say update the exclusion axiom, but an experience of like timelessness is enough to not include time as an axiom?
Yeah, that is a great question. And yeah, I certainly agree that psychedelics and sort of any extreme or peak experience, whether pharmacologically induced or otherwise, is going to be a really good way to kind of examine experience and constrain theories from the sort of first person perspective. Um, and yeah, the example of time is a good one. And yeah, it's hard to sort of um, to reason about these things, right? I mean, it's sort of like you're trying to establish, well, okay, can I conceive of an experience that lacks this thing? Can I even have one? And should I update the axioms accordingly? And yeah, I think that's partly why these axioms are almost sort of tautological properties. They seem like they are so basic that they could not be violated. And exclusion, I think, is one of those. I mean, and the argument there would be with this, experience of boundlessness. That, yeah, I mean, you have an experience of boundlessness, right? But that itself is an experience that, sort of has a boundary in some sense. You're having a very particular experience, so it's specific, and then it has a boundary. I mean, it's hard to, it's hard to describe these things because they sort of are, beyond description, because they're so basic. But yes, I would argue that, in the same way that you can have an experience of vagueness, like I'm unsure of this thing or this thing is sort of blurry or whatever, that experience itself is a specific experience. And so I think the same kind of reasoning would apply to the case of boundlessness.
An
But
experience,
again,
yeah.
people differ. You can do your own first person investigation and then disagree.
Mhm.
So the theory is only as compelling as one finds the axioms, basically. Yeah. But
Thanks.
we tried to think about it and we just haven't well, I guess one thing I'll say is that we really feel confident that these are necessary. Um, and then there's whether they're sufficient to characterize an experience is sort of a little less clear, but we, hope that they are, I guess. Does that kind of answer your question, Michael?
Yeah, more experience of boundlessness versus boundlessness of experience.
Yeah, exactly. That's a very nice way to put it. Yeah. Okay.
I have a quick question.
Yeah, sure.
It's related to your answer. It's I wonder how these actions were constructed and if they're immediate and irrefutable. Like, have you tested two people that know nothing about the theory and like reached the or agreed to the actions being, I guess, actions?
Yeah. So, I mean, I only have sort of anecdotal evidence in that department. And yeah, I mean, I think that, when you have a chance to really sort of sit down and explain to someone what they're supposed to mean, then I've, had some success in getting people to agree that any experience they can conceive of has these properties. But it's not like they're, immediately obvious. You know what I mean? I think this is kind of a part of the issue with Bain's critique. I think he was sort of understanding us to mean axioms in the sense that they're kind of obvious to anyone without any further reflection. And that's not necessarily the case. I mean, it's actually quite difficult to kind of arrive at them and to think clearly about your own experience. I mean, introspection is an active process. It's not always very easy to figure out what's essential to experience and what's not, et cetera. So, but no, I'm not aware of anyone who's actually studied this sort of empirically and like done, some kind of structured test of whether people tend to agree with the axioms or not. I think certainly people disagree. I think there's the objection that Michael pointed to, and then, there's the anecdotal evidence I have that some people I can't convince them, but that's not really that's not the claim. The claim is not that they are, that everyone will agree. The claim is that, when you carefully consider your own experience using introspection, then you don't need any further justification for these things. And we just argue that it's hard to refute. So if someone can try, they can not believe the axioms, but then we just don't find those arguments convincing. So hopefully that kind of answers your question there.
Yeah, thank you.
Okay. All right. Any other questions right now? Just have a few more slides. So. Okay. So I just wanted to cover another objection that was raised in the pseudoscience letter. And this is a direct quote from the letter itself, actually. So the objection is basically amounts to saying that because phi is difficult to calculate, it cannot be measured. And so the quote is, given the complexity of these calculations, it is impossible in principle to compute phi, and hence impossible to identify conscious states, a point that proponents of IIT readily admit. Now, I have a lot of issues with this sentence in particular. I mean, one is that it is not impossible in principle to compute phi. In principle, there is an algorithm. You can run it. And I wrote the code that does that. So I think we have to sort of be charitable and assume that what they mean is that it's not a tractable calculation, and that for systems of a size relevant to empirical investigations, you can't actually run the calculation exactly because it is an exponential time algorithm. And that is something that we do readily admit, of course. But I would kind of draw an analogy here between this argument and this statement. If we just sort of transpose this sentence into talking about, like, let's say quantum mechanics, then it would read, given the complexity of these calculations, it is impossible in principle to compute psi, the Schrodinger wave function, and hence impossible to identify quantum states. And then that is a point that no physicist would admit, actually, right? Because even though the Schrodinger wave function is also exponential time to compute exactly, that has not precluded investigations into quantum mechanics. I mean, we're even trying to design quantum computers right now. So the approach there, of course, is that you develop approximations. You try to find ways of studying this quantity, even though you can't compute it exactly. And this is kind of part of the research agenda that I argued for in my thesis. That's really what is needed for pushing IIT further. I think we have, this exact calculation of phi that's specified by the postulates. What we really need is a mathematical link to other quantities that are empirically tractable that we can use on real data that have some bounded relationship that we can prove to the exact quantity. And right now, we don't have that. That's something that we can only get at using, heuristics. But there's no sort of clear mathematical formal relationship between approximations of phi that have been suggested and the actual exact calculation. And once you have those, then you can go in and start measuring things and drawing conclusions that are sort of firmly linked to the actual predictions of the theory based on the exact calculation. Now, I also want to point out that one of the main rivals of IIT is the global neuronal workspace theory of consciousness. And this was, as many of you probably know, this was tested in an adversarial collaboration, the results of which were finally published in Nature a few weeks ago. And I just want to point out that in global neuronal workspace theory, there's actually nothing to calculate, right? The theory is not a mathematical theory. It does not really prescribe a particular algorithm. And so I just find this objection to be a bit strange because, it's not really a minus for the theory. It's not a minus for IIT that it has a precise quantity, even if that quantity is hard to compute. Because global workspace doesn't even, suggest such a quantity. It's underdetermined in that way. It's not capable of making such sort of precise predictions. So those are kind of three of the objections raised in the pseudoscience letter that I wanted to get at today. And then I just wanted to sort of close by saying, okay, is IIT testable? And so, recall the explanatory identity of IIT. This is the idea that the phenomenological structure of an experience is identical or is fully accounted for by a phi structure or a cause-effect structure, and the quality of the experience is accounted for by the form of the structure, and the quantity is accounted for by the phi value. And that is actually a really, really strong constraint, right? This is the sort of, if we could compute this, this would offer a very, very tight constraint on the predictions that IIT makes, right? So in principle, we're having, the ability to make extremely precise predictions about the border of the substrate, whether something is conscious, and what it is conscious of. And so if that one-to-one correspondence does not hold, and again, I have to emphasize that this should be only tested in paradigmatic cases where these pre-theoretical intuitions about what does and does not have consciousness have weight, then IIT is severely challenged, right? Now, testing this is really difficult. It's always difficult with consciousness, but especially with IIT, given the intractability of the calculation. And so again, we have to develop these firmer chains of inference from the exact calculation to empirical data. That's, I think, where IIT researchers should focus their efforts right now. But the bottom line is that as far as the scientific status of IIT, it makes predictions, and these can be disconfirmed to challenge the theory. And then, kind of getting at Zarmin's question about sort of whether this is a progressive or degenerate research program, there's quite a rich research program that this hypothesis generates. So it's basically all sort of under the slogan, quality is structure. So you can sort of examine, visual space. So the feeling of extendedness of the visual field. So in principle, we should be able to account for that feeling by examining and studying the cause-effect structure that would be supported by, 2D lattices with local connectivity, sort of similar to the way that, visual areas are organized in the brain. And there's a really nice paper looking at this by Andrew Hahn and Giulio from 2019, and then another one from 2023. You can do the same thing for the feeling of flowing through time. So Renzo Comolati has nice work on this, trying to find a way that the cause-effect structure of directed grids can account for this feeling. And then you can, in principle, extend this to faces, recognizing faces, the feeling of general concepts being bound to local features and recognizing objects. And then eventually you can try to do the same thing to account for colors, sounds, pain, these feelings of local qualities in a particular part of your experience. Okay, so that's my high-level overview of IIT. Hopefully I clarified a few things, or maybe I just made it all seem even worse, but I'm happy to take some questions now if there's any other questions.
Beautiful job, Will. That was a wonderful overview and really good sort of addressing the drama, the IIT drama, which, you know, I think science could always use drama. So that,
Excellent.
yeah, I'm going to go ahead and open it up for if people have any questions. Now is the time to sort of ask.
I have one.
Yes, go ahead, David.
So I understand that Tenonia's claim that IIT explains free will, or that an implication of the theory is that like a libertarian free will or true free will exists. I'm curious if you could speak to that, why he would make that claim based on the theory as you've described it.
Yeah, sure. So I can do my best. I was not directly involved in that work, so I will try, but I may not do the best job. But you know, one thing I should say at first is that it's not really a compatibilist. I mean, it is a compatibilist position. It's not advocating a fully libertarian notion of free will. So there's nothing in the account of free will that IIT offers that contradicts, you know, basic macroscopic determinism. So in that sense, it's fully compatible with the idea that, you know, things are predetermined based on the laws of physics, you know, modulo randomness, which doesn't really change the calculus in terms of free will. But you know, it's an argument that that there is a sense in which when you have an action, you should attribute that action to a conscious system, because according to, you know, IIT, it's those systems that kind of exist the most as a whole, right? So that, you know, if somebody, you know, fires a gun at somebody else, and then there's this chain of causation that results in them getting shot or whatever, that the buck kind of stops with the conscious system, with the substrate that's responsible for the conscious decision that was made to pull the trigger, rather than with the bullet or the trigger or the gun or whatever. So that's just kind of a very brief sketch of how this works. But yeah, to be clear, it is not kind of contradicting physics in any way, or claiming that there's some notion that, you know, the sort of colloquial notion of free will, that if all else were equal, you could have chosen differently. It's not saying that. So maybe that answers your question.
Yeah, thanks.
Okay, thanks.
Does anyone have any other questions?
I have one.
Oh, we have a couple of people with questions. I see Nate is unmuted. Nate, and then Zach, I'll have you go.
Yeah, I was just great talk. Thanks for that overview. I'm curious like how you respond to people, researchers who just feel kind of uncomfortable with the way that IIT starts with subjectivity rather than empirical observations, right? So I think we are used to being trained that science starts from some observation of the physical world and then works from there. And of course, that's like really hard with consciousness research for obvious reasons. But it still feels like the way that science is kind of best situated to make progress. Like that's kind of where all of its power comes from. And so this approach flips that on its head, and it's just sort of very it makes me personally feel uncertain that this is a way that can actually work. You know, we know that the other way works because of modernity and freaking quantum mechanics, like you brought up. But this other idea of kind of starting from subjectivity is like totally untested and has not yet provided any evidence of its efficacy. So yeah, how do you respond to that general intuition?
Yeah, no, and that's a very common feeling. I think it's a big part of why kind of there's this group of people that are kind of trying to excommunicate IIT from science by claiming that it's pseudoscience. But I think that, you know, the response really gets back to my claim at the very beginning of the talk, that consciousness is really a special explanandum, that it is different than all other targets of explanation in science, so that, you know, if you're trying to explain some physical phenomenon, it's a given that that's accessible to other people, that it's a third person observable, and you can all kind of, there's some intersubjective realm in which we're all talking about an explanation for that phenomenon. But consciousness really just seems to be different. It seems to be special. And again, there's people who disagree, but then they're kind of forced into this rather bizarre position of having to explain why we think that there's something that exists, or it's something, you know, that we're conscious of or whatever. And they have to sort of explain it away. But if you really, you know, if you buy that it is special on its face, then I think that is a kind of a good, you know, justification for why we have a somewhat non-standard approach. Because if it's a special explanandum, it probably requires some finesse in the explanans, you know. So that's kind of the basic response. And you know, many people just don't find that compelling, and they would prefer kind of a more traditional approach starting from the brain. But then you really run into these problems, which I think are serious, of the explanatory gap and the hard problem. I mean, it's just not clear that if you start from a typical scientific explanation where you're starting in the intersubjective realm and just trying to construct an explanation and uncover the mechanisms, you can imagine all those mechanisms unfolding without it feeling like anything. And then there's also sort of an epistemological response you can make, which is that, you know, actually what we're doing is really just being very, very careful about and very explicit about the kinds of inferences that we're making. Because even when you're doing regular science, it is implicit always that when you're observing the results of an experiment, you're observing it, you know, through consciousness, right? And obviously this leads to a bunch of debates in quantum mechanics, like you mentioned. But the idea is that, yeah, consciousness is really the first thing. It's the only thing you really can't doubt. You know, the cogito, I think, is very compelling. It's like if you had this demon that was trying to deceive you, it could construct all these things. But what you can never doubt is that you are conscious. So I think all of that together kind of really makes it seem like we do need to consider these alternative approaches. And then I also want to say that it's not like we're just sort of proposing a scientific theory from the armchair and just using introspection alone, right? What we're trying to do is just be very clear about how we get from the first person to the third person, right? How we get from phenomenology to physics. We're being explicit about that abductive inference. But then once you're in the physical realm and you have this calculation you're proposing, now we do science as usual. So it's not really like we're trying to replace the typical scientific approach with some other weird thing. We're just trying to articulate very clearly how we get to that in a way
Sorry,
that kind of deals with the hard problem.
that was really helpful. Can I do a note? I mean, there'll be more opportunities, hopefully, to have this discussion. So other people
Yeah,
can
I'm happy to
Yeah.
chat, you know,
Cool.
offline or whatever too. So if you want to get in touch.
Yeah, so it looks like we have gotten to time. Um, Actually, yeah, sorry. Okay, we have gotten exactly to time. But thank you so much, Will. That was really, really awesome. And I'm sure there's going to be opportunities to chat with Will. Let me know if you want to reach out, and I can probably get you guys in contact. But that was really beautiful and awesome, and some great consciousness talk for a group that was really interested in it. So thank you guys. Thank you, Will. And I hope you guys have a great rest of your day.
Thanks so much, Darlene. Take care.